I've gone off and installed the muting section of the receiver, and we're ready to test it. Now, one of the things that builders and designers and everybody does, at least I do, is you go through your project, do it as I'm describing it here, section by section, and test everything so that before you release it to the universe at large, you have gotten all the bugs out of it and everything. And I found a small problem here. I was installing all the parts, and I got to the point where I was ready to install C39, and I couldn't find it. Well, the reason I couldn't find it, it wasn't there. There's a diode D7, then C39, and then R28, and then there's a Q10 and Q9. But you know, I got R28 and D7. Here's D7. Here's R28, and C39 should be right next to it. Well, it is, but it's labeled C33, and that's just when I was, you know, labeling the components in the layout program. Either typoed, wasn't thinking, whatever. Just got it wrong, because here's the real C33 down here on the corner, and I spent like 10 minutes trying to figure out what was going on here, and then it struck me, I fixed it, and so we're all good to go. Now, remember, also you'll note I put a little piece of heat shrink over this diode because it was really annoying. See, there it is. I'm going to move this over, and then I'll move it back. But we have done the audio amp section, and we fed a signal here at this point through C7 out here, and we got plenty of audio. Another thing, remember, I wired this thing so that this is not variable, but the input signal to the audio amp comes through C7 and directly into the base of Q2. And what I'm going to do is, even later, I'm not going to change that. I'm going to leave it like that because I'm not going to use headphones, and I'm not going to use a speaker. I'm going to use a powered speaker, and on it I have a volume control, so I can set the volume there. Okay, how do we test this? Well, we're going to feed a signal into the mute circuit and see if it's not muting. The way we're going to do that is I'm going to do two things. I'm going to feed the signal to R7, which is into the drain of Q26, and that's where the signal, remember, signal comes in through an antenna, goes through this part of the muting circuit, and is going to go through the bandpass filter, through the first mixer, and the mixer outputs the IF frequency. The IF frequency signal goes through the IF filter, crystal filter. Then we're going to go through an IF amplifier here. Then we're going to feed it to the product detector, which is going to take our RF and convert it to audio. Then the audio goes in here. So we're going to emulate this part, the earlier part of the receiver, by feeding a audio signal like it would be after it came out of the product detector. We're going to feed it here and then here, just to make sure that both sides of C3 are working properly. So let's do that. Let's feed the signal to R7, this juncture here. I've got everything powered up, and I've got my signal generator going, and then here's my little probe. So the first place we're going to go is to R7, which is the right-hand side of C3 in the schematic, so that's this point right here. And we get a good signal. Now what that proves is that the mute circuit is not muting. Well, it's not muting because we're not transmitting. So that's good. Now let's try the signal on the other side of C3. Aha! Note, this is on the mute side. Oops, I just bumped my probe here. And this is on the product detector side. And you'll note that it's weaker. Now that does not mean that something is wrong, because look at what is going on. You have a signal coming in here. It's going to pass through C3 and then get to Q26. Audio frequencies are relatively low. In this case, maybe 600, 700 hertz, whatever. What happens to audio when it goes through a small capacitor? It gets attenuated because the impedance to audio for a capacitor goes as 1 over 2 pi f. F is small, C is small, so 1 over 2 pi fc is going to be large, relatively so. So we're going to get some attenuation here. So the fact that the signal's weaker when I input it here versus here, that is not a problem. So everything's working. Now I cannot demonstrate mute because looking at the circuit I need some stuff from the transmitter side, but at least I know that it's not interfering with the building of the rest of the receiver. Have I left anything out? I do not believe so. I think we're good to go. So the next build is, what do you want to build next? Well, I know you want to build everything, but that's not the way to do it. In order for us, the next logical circuit would be the product detector, but for the product detector to work, we got to build the beat frequency oscillator. Now, the signal's coming out of the IF filter into the IF amp, into the product detector is RF, and you can't hear RF. So what you do is you take the RF signal, which will be, in case of Morse code signal, CW, is going to be at a certain frequency, and it comes out of here at 4.0 whatever, okay? We're going to take whatever 4.0 something here and subtract it from there, and that will give us an audio frequency, and then we'll pass it on. And that's what we hear. And the purpose of this little variable capacitor here, C37, is to adjust this so that we can get a tone that we're through the bandpass of the IF filter, get a tone that is maximum and a good one. We'll get back to that. Now, so what are you going to install? Well, you're going to install the coupling capacitor. You're going to install 1, 2, 3, 4, 5, 6, 7. That makes 8. That'll get the BFO, but the BFO needs power. Where does it get the power? It gets it from this Zener diode, D3, and I believe that's 6.8 volts. Okay, and R18, which sets the current so you don't burn this thing up, and that's how you adjust and use a Zener diode. Personally, I would have used an 8-volt regulator here, because if you use or create a constant voltage using a Zener diode, the Zener diode makes a lot of noise, electrical noise. If you look at the K7QO noise generator, or the K7QO noise bridge, I'll come back to it. This is where the noise source comes from. But it's not enough. Maybe it's not enough. Already you've heard that without the tone, the audio coming out of the audio amplifier has no noise in it. We're going to see if we're going to get it when we build this. So let's go off and you highlight the parts that I said you would install if you're going to build this, and we'll come back and see what the results are. And I'll ask you, here's the quiz question. How are you going to detect if this circuit is operational, if it's working? Study for your quiz, and I'll be back. Please give me a like, and I will like you. Thank you.